The horizontal transformation is dictated by h, which we also saw with circles. It was your left-right movement. It does not act how you think it would act. As you increase h, it moves to the right. If you decrease h, it moves to the left. Mike, that looks like it's acting how it should act. Well, it's all about the general form. Let's actually write it up. The graph of the function y equals x minus h is the graph of y equals f of x. Shifted right h units if h is positive. Shifted left the absolute value of h units if h is negative. Two comments I want to make. One, please go back in your notes for the vertical transformations. I should have had absolute value bars over the second k there. I forgot to put them on the board. The reason the absolute value bars are there is you don't tell someone to go down negative 5 units. You tell them to move down 5 units. So if k were negative, the absolute values make the semantics work. Same thing with this guy. You wouldn't say move left negative 6 units. You would say move left 6 units. That's comment number one. Comment number two, as far as me saying something like it doesn't work how you think it would work, if I had this statement, f of x equals x minus 3 quantity squared, what's h? 3. So even though it says negative, it's not really negative because according to standard form, the format is x minus h. We have x minus 3, so h is positive 3. So what direction would this have moved in? To the right, because h is positive.
So that is moving right?
No, it's just, this is here for semantics to help it make sense. So if, for instance, I gave you g of x, this is the one that's in the homework, the absolute value of x plus 5, that function. So this is really x minus negative 5. So that means h is negative 5. But you wouldn't tell someone move left negative 5. You would say move left 5. So if you add to the function, you move up. You subtract from the function, you move down. Add to the variable, you move left. Subtract from the variable, you move right. So again, that's that prepositional phrase we have to worry about. Add to the function up, subtract to the function down, add to the variable left, subtract from the variable right. So let's try an example. Awesome. Explain the transformation necessary to sketch the graph and then sketch the graph. F of x is the square root of x plus 1 and then minus 4. So if you would write, what shape are we transforming here? What does it look like? Half of a parabola sideways. Good. So the graph of a square root looks something like this. Okay? Now there is an order of operations, if you will, as far as the order in which you want to do the transformations. For right now, it does not matter until we get another transformation on the board. But typically you work inside out. So let's first apply the, that should be a parenthesis there. Let's apply the y equals square root of x plus 1. So taking the original graph of the square root and now adding 1 to the variable, what you're really doing is subtracting 1 from all the x coordinates. So what direction does this move in? Left 1. Good. So we take this graph and move left 1. You'll have that kind of shape. X plus 1. One. Sure. By adding 1 to the variable, what you're really doing is you're subtracting 1 from the coordinates. So think about it. Where this graph began was 0, 0. So what number would you have to put in for x to get a y value of 0? Negative 1. So what happened was this point 0, 0 moved left 1, which means all points have to move left 1 now to make up for that. So again, k does what it says it's going to do to the y-coordinate. If you add to the function, you're adding to the y-coordinate. If you subtract from the function, you're subtracting from the y-coordinate. For the h's, it's the opposite. If you're adding to the variable, you really subtract from the x-coordinate. If you subtract from the variable, you're really adding to the x-coordinate. And now the minus 4 is doing what to what? Is subtracting from the function. So that's our h. So if k is negative 4, what does that say to do to the graph? K says move down 4. So taking the graph in green, we're not going into the graph in blue, taking the graph in green and moving down 4, that's our final answer there. When I'm grading these, I'm looking for shape in position. Did you pick the right function? Is it in the right place? Correct. So basically, I want you to approach this like a cookbook. This is the first step, and now applying the new step to the previous step. Yes. So if we needed to write this in standard form, this would look like the square root of x minus negative 1, parentheses, minus 4. So this needs to look like x minus h, so the h would have to be negative 1. Yep. So this is all I'm looking for. If you want to do the intermediate steps, totally fine. Have no problem with that. On the test, though, I'm only going to give you one set of axes. But I don't care if you use the back of the test or whatever to draw in more graphs. Totally fine.